Okay, we're online and we are now streaming. And welcome. Thank you very much for joining us again after the Salah prayer. And I'm very happy to welcome to the stage for a fireside chat on his expert field. We have Professor Salim Al-Babili, who is Professor of Plant Science at the King Abdullah University of Science and Technology. Thank you very much for joining us today. I'll take my seat next to him and we will start the fireside chat. Good afternoon, Professor. Thank you for joining us.
Good afternoon. It's a pleasure for me to be here.
Thank you. Before we start, could you just tell us a little bit about yourself and tell us about the Plant Science department at KAUST?
As you just introduced me, I'm a professor of plant science and bioengineering and associate dean at King Abdullah University for Science and Technology, KAUST. I'm a trained biochemist, joined KAUST from Germany in 2013. I have made significant contributions to increasing provitamin A content in different crops, aiming at combating vitamin A deficiency. I'm heading a consortium to combat parasitic plants in Africa, which represent a major threat to global food security. And I have aimed during all my career to translate discoveries made in my lab into real-world application. The plant science program and people working on plant science in KAUST are diverse. They are covering almost all important aspects of plant science, starting from genomics to gene editing to metabolism to development and breeding. And we just founded the Center of Excellence for Food Security, as you know, that was launched 2 days ago here.
That was the big news when the minister inaugurated the event, was the announcement of that facility. So that's all very exciting news for food security in the kingdom in the future. So congratulations for that.
Thank you very much.
And I'm going to start off with an expression, engineering crops, because that seems to be your speciality area. So we have an online audience and we have you as well. And we have our audience with us today. What is engineering crops? Because I have no idea.
I mean, engineering crops means modifying crops, aiming at improving certain traits or enhancing some specific features, such as tolerance to drought or pathogen resistance, or modifying the architecture that you can increase the yield in field, or you improve the ability of plants to absorb and utilize nutrients. It's typically used to describe a targeted and specific modification of the genetic makeup of a plant. This can be done either by classical genetic engineering, which refers to introducing a gene from another plant or from the plant itself or from another organism into the plant, or it refers to gene editing, which describes the precise and targeted modification of plants' own genes. You can modify one single base, you can modify a few bases, you can knock out a gene or introduce another gene by gene editing.
So what is the laboratory process behind that engineering? Where do you start and where does it end up? So I'm a learner, and there may be some...
I think you know very well what's about. It starts with identifying, of course, the genes responsible for a certain biological process. You identify a major player in such processes, and then you can, if you use classical genetic engineering, you would use a vehicle that is Agrobacterium, usually, an Agrobacterium species, to bring the gene of interest into the crop. This is usually followed by a selection process to identify the plants that have this new trait, this new gene. Gene editing is based on CRISPR technology. You know that you use a guide RNA, uses certain enzyme. This guide RNA is identified and designed based again on the gene of interest within the plant, and then you introduce this combination of tools. In principle, this combination of enzyme, guide RNA, usually also antibacterial resistance, antibiotic resistance into the plant, and then again you look for the plant that have obtained this trait and
Excellent.
that have been edited.
And in terms of food quality, the genetic modifications and editing, they improve plant traits for quality. We came up with flavor earlier, also yields. What are the concerns of quality in terms of the health of consumers? I mean, with the plant itself that you're editing, perishability, flavor, just general quality standards.
I mean, generally these technologies are safe. When it comes to quality of food, it depends, of course, on the gene that you are modifying. But in general, of course, you would select the gene that would improve the quality and not affect it in a negative way. Interestingly, you know, when we use classical breeding or crossing, we would change the genetic makeup of a plant in a far more severe, more significant and unpredictable way than we use gene editing or even genetic engineering. The issue with these technologies is that there is a lack of information, so we need actually to educate consumers and make them aware of the advantages of these technologies before we can actually get to implementation of this technology and see the positive effects of its usage in practice in real life.
So the implementation of the science through to the consumer, and in particular the logistics, the movement of the plants or the product from the farm all the way through to the table, the storage in the supermarket, and all that. How do you create the laboratory conditions to make sure that when it lands on my plate in front of me in a restaurant, that, you know, by gene editing everything is going to, you know, be successful? Or is that quite hard to research?
It is, you know, gene editing and genetic engineering one component in such a complex process. You know, making food and bringing it to the table is quite complex. And as a scientist, you know, you usually look for one component, and then you need to work with other people with different expertise who can cover this also very important aspects, of course.
Yeah. So you work with other people in terms of all the way through the value chain and back to what you're doing in the laboratory.
We do. I mean, we work with other people, but we don't go so far, you know, to the restaurant.
Okay.
That's a little bit far away. But we make sure that what we are doing is safe and that what we are doing has the quality that we are anticipating.
So your implementation is from the laboratory to the farm?
In principle, yes. Actually, from pipetting in the lab, from gene discovery, from analytical chemistry to the field.
Okay.
And that is a long way, you can believe me.
That's still a long way, I'm sure, yeah, absolutely. The research covers abiotic stress and plant development. Can you just give us more of, I'm not sure what that means. Somebody wrote that down for me.
I mean, abiotic stresses describe the negative impact of physical or non-physical factors or factors coming from non-living environment on plant productivity and growth. You know, this include drought, extreme temperature, flood, lack of nutrients, and so on. It is distinct from biotic stresses that are related to pathogens or to harmful insects and so on, that again affect the performance of plants and crops in general. Plants cannot move, so they cannot escape such traits and such stresses, though they have, of course, evolved many strategies to mitigate and cope with these stresses. Nevertheless, abiotic stress has a severe impact on food security, which is now more intensified with the climate change.
So in terms of food security, the main elements that you need to incorporate into your thinking before you start researching, what are those? I mean, what are you looking for? Higher yields for one. What other elements are you considering?
Pathogen resistance, resilience. I'm working on root parasitic plants that usually affect cereal production, for instance, in Africa, and they are considered as one of the major biotic threats to global food security. We are trying to develop genetic-based and also hormone-based solutions for this problem. I'm getting actually funds from the Gates Foundation to work on this project. That is causing huge losses, particularly because these losses are related to food, to the daily food, and not to something luxury that you would actually afford to lose it.
But this kind of innovative research, there must be, there's emotions attached to your work. There's success, there's failure, there's a lot of things that happen. Tell us about some of the great moments that you've had in the last year or two, and some of the moments where you've kind of questioned about what you've done.
Actually, one of the greatest moments in my scientific career, it's a long time ago, is when we got the first generation of golden rice and we saw grain that are yellow. And then we did the analysis by HPLC and we saw the product there. And that's something that I would never forget, of course. But working in the lab and to a more severe and pronounced degree, translating research into the field is always accompanied with disappointments, with failures, with experiments that don't work or miscalculations and so on. But having the goal of translating research into solutions for real world problems is very rewarding, and this give you the power and the energy and the patience to survive all of this.
It's quite emotional, really, that kind of research, isn't it?
Of course it is.
And obviously you and your team must be quite close because of that emotional bond that you develop of the up and down.
You have to identify yourself in principle with the project that you are working on if you are going to work on such projects.
Thank you for the personal insight. I think that's very interesting. So let's talk about crystal balling in the future. How do you foresee engineering crops, the engineering crops of the future, and how they will contribute to Saudi food security? I mean, what's on the horizon for your field?
I believe genetic engineering or engineering crops is essential for ensuring food security. We need to increase the productivity of crops. We need to increase their nutritional value. There is a phenomenon that's called hidden hunger that describes actually lack of minerals and essential vitamins in the food. And that is as severe as lack of food itself. So we need to increase the productivity. We need to improve the quality of our crops. At the same time, we have declining resources and we have challenges that are posed by the climate change. We need to reduce the ecological fingerprint of agriculture also by improving the ability of plants to absorb and utilize water and minerals from the soil. We have to explore the possibility of generating new crops by new domestication. These new crops might be able to grow under unfavorable conditions, which we are expecting to prevail more in the future. All of these objectives, and particularly we are living in a very arid area, all of these objectives need actually efficient and time-saving technologies, and these are characteristics of genetic engineering and gene editing. I cannot imagine a future for food security without using these technologies.
Excellent. We've come to the end, and I just hope all of you will wish... Oh, do you have a question? Do we have a microphone for a question? We have a member of the audience that has a question. A microphone would be fantastic. Do you mind, Professor, answering a question from the audience?
Sure.
Yes, salam
Pleasure.
alaikum.
Wa alaikum salam.
First of all, I would say that I am delighted to have Dr. Salim with us today. As he mentioned, and people know, I think he's a pioneer scientist, and he was one of the innovator of the golden rice in 2000, which was something unique in the world, which is important for malnutrition. That's one of the importance of the genetic engineering, I guess. My question, because we are talking about this sustainability, what do you think, I mean, if I go to agricultural practice, we have the organic farming, which they don't accept GMO in their way. And have you heard my question?
I have a little bit difficulty.
Okay,
I'm having difficulty as well.
Okay.
Sorry. Can you ask in
Sorry,
Arabic?
the mic. Is
Mike, maybe it's a problem. So I was saying, because we are talking about sustainability here.
Yes.
So we need to increase, of course, the amount of food, the quality of food, and so on. So from your opinion, when we compare the organic farming, as they don't accept using the GMO or the genetic engineering technology, and the conventional agriculture, as if you develop a crop which, as you mentioned, 20% drought tolerant or whatever, or the yield is more. So we need more. As the lecture before was saying that by 2050, the population will be about 10 million. So which one is going to be more sustainable and less fingerprint and good for our planet, in your opinion?
You mean a comparison between organic farming?
That's what I'm
and
getting.
classical
Yeah, comparison
agriculture?
between.
But because with the new technology, I'm not talking.
Thank you. I think we've got it, sir.
Yeah,
Thank you very much. I think what the question is here is a comparison between gene editing and organic farming, and then also taking externalities like climate change, desertification, and those kind of into account, which is
I'm of
going
course,
to provide sustainability.
I'm of course not against organic farming, but I believe that there is no other way than using gene editing and genetic engineering if we want to provide food for this growing world population and as I said, declining resources and the challenges posed by climate change. I need to repeat myself. The major issue that I see is the lack of information. We need to educate people actually and tell them what is this technology about. It is of course much better than using hard chemistry to combat pathogens. It provides a lot of advantages because the changes that you are creating are known, precise, and predictable. What will happen is actually predictable. Give you an example, a long time ago there was a survey in Germany about genetic engineering and modified plants, modified organisms. And it turned out that a significant part of the population thought that only genetically modified tomato contained genes and DNA. They believe normal tomato doesn't have genes. And You know, we have actually to stand and explain to the community and to the consumers what these technologies are. If we don't do that, we will always have opponents that don't know actually so much about the technology, and therefore they are against it.
Okay, thank you. Everybody, let's just wish the professor well for his new centre that's just opened, and also wish him well against all the challenges that he's facing in the laboratory, and hope for lots of successes. Give him a big hand, please.
Thank you very much.
Thank you very much, Professor. If I could ask you to take your seats for a short presentation. People have requested Ms. Al Anud to readdress the audience from the inauguration day, because she had some incredibly enlightening information for us. So I'd like to invite her up to the podium to do that again for us. Thank you very much.
Thank you, Doctor. Good evening, everyone. And thank you all for being here with us today. I think this session is one of the most important sessions within the exhibition, especially with the presence of our valuable and expert speakers who's joining with us today. I would like to stress on the importance of the vertical farming on promoting sustainability and reducing the water consumption, and also it might localize the important crops that we would like to have in our kingdom, like strawberry, for example. Also, I would like to mention some ministry efforts that has been made to support the vertical farming. 2 weeks ago, the ministry sponsored an agreement between At-Tamimi and one of the company called Mitsui to develop one of the projects in vertical farming, especially in aerobic techniques. Also, during this year, the ministry hosts an opening for an urban farming in one of the largest hypermarkets in Riyadh. And urban farming actually is one of the initiatives that we are working on, and we would like to expand on it in the future, inshallah. I will not take too much time. I will let Dr. James to lead the session, and wish you enjoyable session. Thank you all.
Okay, we're on to our next panel. Live streamers, are you ready? Yes, they're ready. Everybody at home's ready, or in the office is ready. And I can see that you all in the audience here with us live today are ready. So we're going to move on to our next session. The controlled environment, agriculture, new trends in vertical and peri-urban farming. So that was a lovely introduction by Ms. Al Anud. And we're going to invite onto the stage now JB Robert Burrows, Martin Alexander Voss, Sky Kurtz, and Estella Sun. Please come up to the stage and take a seat next to your names, please. And I think we're missing Mrs. Sun. She was here earlier. Oh, there you are. Great. Thank you very much. Okay. Joining us, and the people with headsets, you're very lucky. The people without headsets, not so lucky. So if you have a microphone in front of you, Mrs. Sun, you need to be quite close when you speak in the microphone, please. Okay? It needs to, so we get the recording and the people at home can hear us. But what I'm going to ask you to do first, Ms. Sun, if you could start, could you introduce yourself and tell us which company you're from and what you do at that company?
So I'm first the one, yes. Okay. Hello everyone, I'm Mr. Sun and I come from China. I work in Chinese company, China Green Agriculture. Currently, we already registered in Saudi Arabia, so we have office here. We have 115 labor here. And we have taken 3 projects in King Salman in KSA. One is in King Salman Park, one in Red Sea, one in Yamama. So we also want to build a new factory here because most of the factory in China at present, but we are focused on Middle East market. So we moved all the factory to KSA, will be step by step. My position in this company is business manager. We want to build a new market and business partner here. That's all. Thank you.
Thank you.
Nice to meet you all.
Thank you. Mr. Kurtz?
I'm Sky Kurtz. I'm the co-founder and CEO of Pure Harvest Smart Farms. Pure Harvest is a technology-enabled agribusiness based here in the region with operations currently in the United Arab Emirates, also in Saudi Arabia, and expansion efforts underway in Kuwait, Singapore, and Morocco. And we are vertically integrated. We design, procure, construct, operate, market, sell, and distribute our produce. A broad variety of produce, including tomatoes, strawberries, blackberries, raspberries, leafy greens, including spinaches and rucola. And we do so under our flagship brand, Pure Harvest. And for those of you who shop here in the Saudi market, you'll see us in grocery stores, but also in the UAE, Kuwait, and Oman. So really, we were an early entrant to this space in the region. We started the company in 2017. We've raised now about $287 million of capital across multiple capital raises and deployed that capital building what is now a profitable controlled environment ag business. So a pleasure to meet you all. I also see some of my partners in the audience. So we also work with many of the industry partners that are here at the show.
Thank you. And if you could just talk a little slower, because some of the people at home might not be able to get all that. Okay, thank you. Sure. Dr. Martin, if you could introduce yourself, please.
Thank you very much for having me. I'm Martijn Vos. I'm a mechanical engineer by training. I've spent most of my time in the aluminum industry. And I'm overseeing the commercial activities of MPI Ultrasonics. We are an ultrasonic, high-power ultrasonic company. We produce our own technology. And we recently finished some very promising projects in the agriculture with universities in the United States and in Portugal. And I'm here among agricultural experts to find companies and institutes that are interested to explore ultrasound to accelerate the agricultural processes in seeds, in water, and in soil treatment.
Thank you. And Mr. Burrows.
My name's Jamie Burrows. I'm the founder and CEO of Vertical Future. We were founded in 2016. We're a global vertical farming company. We design, manufacture, fabricate, and deploy autonomous vertical farms, so all the hardware and software is in-house. We work across multiple use cases, so not just growing food, but also forestry, alternative proteins, and similar. About a team of 60. We've worked with lots of different organizations across the world, members of the World Economic Forum, and the World Green Economy Organization. We're very interested in the Middle East. We're setting up offices here, and obviously this is the region which is in most need of our solutions.
Thank you. I'll come to Mrs. Sun first. Your company has developed the latest smart agriculture solutions. What give us more detail about what you're doing in KSA in the factory that you've established?
Thanks for your question. Yes, our our company is focused on the latest technology. Our booth in the hall 2-277. If you come to our booth, you can see there are so many crowded around us because we have imported 2 demos from China to here that can show, and everybody when they saw it, they will say, "Wow, it's excellent," because it's totally sure the latest technology. From one seat, from seating to harvest to parking and to clean, or you can use automatic, no need a human being to do it by themselves. Actually, maybe you need 1 or 2 labor or just a few of labor. You can just sit in at the office and monitor by CCTV. But no need you go around and to do by yourself. You can just sit in the room and monitor all the data, like the air, the humidity, the temperature, the oxygen, all things, and you also can see the status about the plants. And for example, vertical farm is popular in the Middle East, and it's a closed environment. Also, sometimes it will require all clean water, clean environment. So we are not allowed people come in. You just can stay outside and monitor all the data in the display. So I think this is one point. For another, you can come to our booth and see and saw it. There is a machine arm. It can to pick up, harvest by all the automatic. Like 1 million, it can harvest 18 seeds. It's very quickly. And for 10,000 square meter, you can just use the one machine is enough. One machine and 2 labor is enough. So I see, in my opinion, in my few words, maybe you can't get the more detail about the latest technology. But if you can go to my booth, maybe you can know, wow, it's wonderful, it's excellent. Welcome you all.
Thank you. We'll come and see that later. Mr. Kurtz, at Pure Harvest, you talk about reimagining farming. How are you doing that exactly? What's the technology behind it?
Well, so I think what was unique about Pure Harvest was not how we farm. Ultimately, well-established controlled environment agriculture companies have existed around the world for a long time. There's great brands and companies in America, for example, NatureSweet, Mucci, Mastronardi, in Holland, Loya, in Morocco, Azura, in Australia, Costa. So we're not alone or new in this industry. What we saw as an opportunity was that we asked ourselves, why are not a lot of these companies sitting within 4,000 miles of the equator, where there's all the sunlight? Intuitively, you would grow food there. But really, anywhere within that band is seasonally or year-round import dependent in fruits and vegetables, the ones we all enjoy to eat and consume. So we saw an opportunity that if you could develop a solution to manage climate economically and energy efficiently in that environment, you could not only produce year-round and produce produce in the area, but we believed that you can produce some of the best produce in the world, because ultimately you're growing the same genetics. We source them from all the same companies, half of which are in that room, but you're also doing so with an incredible amount of light and with CO2, right? We inject CO2 into the greenhouses, and fundamentally photosynthesis is the same anywhere you're doing it: sunlight, CO2, water, and nutrients. But there's a lot of sunlight and a lot of CO2 in this region as the hydrocarbon capital of the world. And so we saw a potential that we could, maybe the contrarian thesis and insight in the company was that we could not only be competitive, we could have some of the best produce in the world. And now we've proven it. We've won awards in many places. We shipped our product to Belgium to compete in the International Taste Competition, and we won the awards that are essentially the Michelin star of produce. We're producing now strawberries that are now, I would say 80% of the year, the absolute best product in the market. 20% I have to tip my hat to the British and Scottish and other berries that are air freighted in season and still better, though we're getting better every year and learning what genetics perform. So what is unique about us, I think, is that we've taken a proven model that has worked around the world, but we innovated around the two specific areas that were failing here. It was climate management, the tools and the software that controls that climate system, and what I call the construction tech, building redundancy, resiliency, using composite materials or other solutions that enable that system to be resilient in this extremely harsh operating environment. And I think that those were the innovations. People characterize the company as ag tech. We are not ag tech. We work growing like many of the best players in the world. What we've done though is innovated around the failure points or the critical points that were needed to make that solution applicable and scalable here. And then the other elements of it, that's just the growing solution, which everyone focuses on. But that's 30% of the picture. You've got to operate it, you've got to maintain it, and you've got to commercialize it. And I think that that's a huge challenge. You need a significant professional approach and scale, because in the end, we're really 6 companies in one. There's the technology, buy, builder, partner in tech. There's the farming, right, agronomical science, etc. Manufacturing, just-in-time management in a perishable good that's highly regulated with food safety and etc. You're an engineering construction company. You take the bare earth to the built environment from, construction management, permitting, yada, yada, yada. You also are an FMCG company. You're having to work with retailers, online, offline, building a brand, trade marketing on digital channels, and do that across seasons and seasonal dynamics. And last but not least is you have to lobby, right? You're ultimately working with governments that are deeply involved in what is a critical sector in anywhere in the world, and one that's semi-protected, right? There's domestic farmers that are a protected class. So I share that because when you ask what's unique about us, it isn't necessarily the technology. If we gave it away, it wouldn't help people. It's ultimately the entire picture of
Thank you. Power ultrasonics, Dr. Martin. Can you just tell us how that works in agriculture, so all of the audience out there and at home know what that is?
Yes. For us, it is quite new. We started this work when we got asked by a university in the US. And recently we did a project with a university in Portugal. And what they did using our high-power ultrasonics is we agitate water. And we create what is called ultrasonic cavitation. And these cavitation bubbles you might know from a screw from a ship. And that's the same with ultrasound. These bubbles expand and contract and expand and contract. At one point they implode and they create extremely high pressures on a local scale of 500 bars.
Wow.
Also temperatures occur of 5,000 degrees Celsius on a very small scale. So it's very stormy water, so to speak. And the seeds get micro cracks. And I was blown away when I saw the results that the germination improved by 30 to 40% because of this. And we learned that it only takes 5 minutes of treatment in 200 watts, and you're there. And I think this technology is ready to go to the next step, to do larger scale trials, to do more seed trials, and then roll it out into the market. It's a natural process. We're not adding anything. We're just using a natural phenomena, being ultrasonic waves, to do this. A similar application is to use the same cavitation and to treat water. We did a project with a university, with an institute in Geneva, where we used high power ultrasound and ozone to treat wastewater and completely sterilized it. So I'm thinking to take the next step and use high power ultrasound to treat irrigation water and to homogenize it, to break up all the clusters you have in the water and to make it easier for the plants to use it. So I'm looking for companies who are interested to do these kinds of projects with us and to bring these technologies to market. We are using high power ultrasound in wastewater treatment today, not in agriculture yet. So I'm looking forward to these challenges.
Thank
I
you.
think we definitely have a place to contribute.
Thank you. Well, the germination process success is pretty astounding, really.
Yes.
I suppose that also can translate through to vertical farming, can't it, Mr. Burrows, in terms of success and yields?
Yep.
Tell us a bit more about the vertical farming that your company is involved with.
I think first and foremost, we're a technology developer, so and we're very science driven. So we spend our team spends our days and sometimes nights developing new crop algorithms in terms of that will advance the sector, and general know-how is very important as well. We continually run trials on different types of crops, and the hardware that we develop and the software that we develop obviously is always on a continuum. A couple of different, we're also leaders in research for the United Kingdom, so we participate in a lot of grants and work with different organizations in different areas. So a couple of examples I could perhaps give to you. The forestry aspect of our business, i.e. growing nursery trees where there's a huge deficit. If you look, for example, in the US, there's 3.5 billion trees that die every year, and there's only a couple of 100 million that are grown to replace them. And I know that the Kingdom has very big targets for 2040 for trees. We found that through effectively tricking the plant by using different wavelengths of light at different times of the day, in combination with many other different factors and variables, we've been able to effectively create much healthier plants that can be then effectively transported to being planted outside. So, for example, we're working on a project in the UK with the Blenheim Estate. They previously, through traditional methods, were doing the nursery processes and were losing 60 to 70% of their plants in the first year. And then if you look at how that relates to the carbon markets, that's not a good thing, clearly. Through simple trials, over 1 to 2 years, working with one of our partners, A Healthier Earth, we were able to demonstrate a loss of less than 10%. We've also worked with different types of plants in the alternative protein space. So, for example, we found a plant that has about a 40% protein content, and if you compare that to chicken, for example, which is about 25%, this is another use case. I could go on and talk about pharmaceutical projects and things as well. But naturally, our main focus is food and water security, such as obviously this is the name of this session, and that's where our main focus is. I think there are a lot of proof points that have been reached in recent years. We know that vertical farms are far more water efficient, irrespective of whether a low-tech or a high-tech system. We know they're very space efficient, and your productivity per meter cubed is always going to be better than outside. And we're now reaching a point in scientific, peer-reviewed literature where we're finding that actually, even with the power that's required to power vertical farms in certain geographies, it's very geography dependent, that we can actually grow plants that are healthier with less energy, even compared to outdoor growing. So I think the sector is very much on the up, and I think a lot of the challenges, when you initially talk to a prospective new client who potentially wants to do a trial with you or buy your farm, the first question is, well, it's very, very energy intensive. How does that work? Why is that better than traditional agriculture? Well, we're in a geography where temperatures can reach in the 50s and more. So I don't believe that vertical farming is the single solution. I believe that in the future it will form part of the chain, which is high-tech glass houses. We're already doing projects where we're integrating with them for the nursery phase. And then obviously traditional farming so that we can flatten out that curve across the year and create stable and healthy food production for the kingdom and other geographies all around the world.
Can I just ask a question out of pure interest? It's off the script, but I've seen photographs of vertical farms in cities. And how do you balance out that yield, productivity, and profitability with the real estate prices? How is that a solution, or is that just a hype?
So I think the natural, if you think about the evolution of this sector, that there are plenty of vertical farms in cities. I don't, if they're there, they're there. I don't think it's particularly necessary. I made the point that vertical farms have proven that they are, more productive per meter cubed. That doesn't mean that they need to. That doesn't mean that they need to be in cities. The perfect location for vertical farms is in, rural areas, anywhere, even if it's 100 miles away from any city, say from Riyadh. That's a hell of a lot better than importing it from across the world, as we know is being currently done. Because if you're placing more and more vertical farms in cities, there's an evident trade-off and a negative externality where you could otherwise be putting other urban infrastructure. The one thing I would say though is there are good use cases for for smaller farms that are not necessarily farms that can produce at price parity, but that can raise awareness around training, education, health, and so on, that should be in cities. But I think they should be extensions of much larger, scalable farms. And I guess my last point, which supports that, is that I think that at the minute we're talking about leafy greens, strawberries, tomatoes, and so on. There's a natural limitation unless you integrate with high-tech greenhouses and so on. If we want to unlock, more crops and more staple crops, those kind of key protein crops and things like wheat, which is way off in terms of unit economics, we need massive farms and massive capital investment, and that's not going to happen in cities.
Yeah. Mr. Kurtz, I just want to continue this point about education and training, because you're introducing this new technology, just like Mrs. Sun is introducing this new technology. What about capacity building in colleges? Because I know that we've got some students here from agricultural colleges here with us today. How do we equip these young people to deal with these new technologies? What's the challenge for you to get them to understand, to get them to be able to get their hands dirty and use the technology?
We are actually, it's a huge concern for us. We believe that to be a truly scalable company and industry, it's quite critical that we actually develop local talent, because we have farms in remote areas, for example, Harad, which is 2 hours and 40 minutes from here, and Al Muzahmiya, which is an hour and 25 minutes from here. And there's only so long that an expat who's from Europe or America or somewhere else will want to live away from their family and their culture, farming in a remote area. It will inherently be a transitory leadership role. And so what we're trying to do is capacity build and capability build locally. We started that in the UAE, where the business began, and we've launched a Growers Academy. We already are hiring Emiratis and training them. We have several that are agronomists within our organization, and we are looking to replicate that program here, and we'll do so. Our company is currently securing capital to expand, but in that next phase of growth, we'll have sort of the capacity needed to begin that effort. but I think it's a really important piece of the picture. With regards to universities, we have not partnered with them yet that we would like to. There are proven grower academy relationships, like for example, NatureSweet did so in Mexico, and we think it's a great model, but it requires both resource commitment from us, the companies, but also from the universities and possibly from the government to support, because it takes time and money to invest in educating and developing people. But we see it as an important piece of building this industry, right? We want people who are from here, want to live here, have families here in the networks that keep them within the company, because we're not building a project that we're going to flip to somebody. We're building a agribusiness infrastructure. These assets live 35 years. We better have workforces that can serve them during that time, and that will be about capacity building. But I want to comment on one thing though, is I think the expectations of, for example, my leadership team lecturing at schools to teach people to grow, we're still getting ourselves to scale, right? This is a relatively young industry. If you look at Holland, which has an incredibly developed infrastructure and industry, it's one of the leaders in this industry. They've been at this for 100 years, right? And even over the last 30 years, incredible expansion. And they have programs in multiple universities like Wageningen, where they build capacity. That will happen here. KAUST has a program focused on this. But I want to say that it's going to require a commitment on both sides. And Pure Harvest is open for business, right? We really want to be leaders in that.
You want to be involved in that capacity
And
building.
we think it's critical to scaling our business.
Good. And Mrs. Sun, what about your new factory? Where are you going to find the talent? I mean, what's your plan for that?
For vertical farming,
Who's going to operate the factory, and where are you going to find the young farmers to do that? Have you decided how that will work?
yes. And for IoT, international of things, I think it's very helpful and useful. It's like this. We are focused on greenhouse, shade net house, nursery. All part will need data. But if we, without IoT, we will come to every part and collect data. But if we have IoT, we can combine every data and every section in one room. So if you just, like we have undertaken King Solomon Park. King Solomon Park is very, very big. We have 10,000 for one shed house. When we have IoT inside, we just can require 1 or 2 labels, sit down and just collect the data, like the air temperature, humidity. So I think if we can make also the person who in charge of this IoT will appear in display. So I think we can just improve and where to strengthen this IoT, and it will be popular in the market.
Thank you.
Thank you.
We're going to switch back to ultrasound now. In terms of the greenhouses, because, we're talking greenhouse, we're talking, controlled environments. How does your ultrasound help in those particular environments?
We haven't demonstrated it yet, but I'm convinced that if we use ultrasound in vertical farms, for example, we improve the quality of the water without any additional chemicals, and it will improve the yield of the vertical farm. So I'm really interested to demonstrate that.
And have you done any trials yet in this respect, or are you just at the beginning of this?
We are just at the beginning of that. We've done a lot of literature studies. There's a lot of work done around the world. There is a major difference between the ultrasonic technology that we use and the standard out there. The low frequency ultrasound which we use is normally at a single frequency and works as a torch. So it's very effective, but only locally. What we do, our signals are programmable. So when we treat water, we are able to homogeneously agitate. And we are therefore much more effective than normal ultrasound, I would say. So I've noticed that several people have tried it. They said it doesn't work. So we also have to educate there, and we have to deal with that. But every project we've done so far, we've shown that it works. So
Excellent.
I'm looking forward to these vertical farm exercises, to be honest.
Okay. Mrs. Sun, I'm going to come back to you. Innovations in smart agriculture. What do you see on the horizon to be developed next? What is China Green working on for the future?
I just wanted to make an example for agriculture. Is when you fish farming, you without changing the water. When you to plant the vegetable, you no need to fertilizer. That is why, because we use the intelligent agriculture, not the traditional. If traditional, you can't combine them together. But if you use the intelligent farming, then from this is fish, this is vegetable, you can make the water treatment inside. After when you fish, there will be excrement from fish and feed bed. But if something you can make on the water, you can filter it, then use the water to the vegetable. Also, the excrement about the bed is useful and helpful for the growth of vegetable. Also, when you filter the water up down, then the water will be cleaned again. Also, can come back to the fish. I think if the smart agriculture is a future trait, it will combine everything, not normal in current center.
Excellent.
Thanks for your question.
And Mr. Kurtz, what couple of minutes? What have you got on the horizon? What's next for you guys?
We've launched a couple of interesting things. Some technology, which I'll cover, and also some for the consumer. So on Halloween, on October 31st, we're launching a product line of pasta sauces, shakshuka, and strawberry jams made from our second quality or ugly tomatoes and strawberries, which is a cool innovation for the consumer, and the products are really delicious. But that's a way, like a unique extension of our brand and our product into new categories. That's one example. But also, we have over 7 years of accumulated data, of operating data, and we're doing interesting things for that. An example is we developed an ensemble learning model, a yield forecasting model that allows us to take light, climate data, and the historical performance of crops by variety, and then essentially estimate the yields with incredible accuracy. And there are others after this problem in the world, but we're uniquely able to use our data, in this region, we're the only ones with a long history of operating in it. And that's creating a really interesting use case of our data. Another example, we developed a application that our growers use. We call it a co-pilot as a nod to the current AI revolution. But the growers are able to take images of the crop and take unstructured data to a structured environment. So they tag, we see white fly pressure, or we see the crop out of balance. And then that data builds a database of interpreting that crop in the same way the grower does. We've been doing this for almost a year now. Now we're able to use AI/ML applications to provide alerts. So we take images of the crop, and then the grower, it alerts the grower, hey, over here is white fly pressure. And as we build that data set, the application becomes more powerful. We're training new growers on it, and a grower is able to grade another grower's work, if you will, right? And so we're able to train and develop and monitor interpretation skills, and that's an example. So we're now, we call it FUBU technology, for us, by us, and we develop it. Once we prove its application and its worth, we'll commercialize those solutions.
Excellent. Mr. Burrows, what about on your side? What have you got in the pipeline? What's happening in your world, your vertical world? What's next?
So, I mean, just to add on to that, I think, our farms essentially, I come from a healthcare background before setting up Vertical Future, so I'm kind of a health economist. we look at a farm almost like a hospital. So you build the infrastructure to be preventative, so the crop has the best possible conditions as possible. The fact that if you look at our farms, they're all built of high-grade stainless steel, smooth edges, so you prevent the buildup of bacteria, and all of our trays move through the facilities with barcode sensors. So we can actually track to essentially 0.25 square meters, what's on a tray, who seeded it, when it's going to be coming through the farm, and so on. But the ability to move a tray autonomously through the system, obviously driven by our software, with very limited operator input, and the input doesn't need to be specialist, allows you to take it through these, what we call kind of treatment areas, diagnostic areas, which is very similar to what Sky was mentioning. So for example, hyperspectral imaging, which allows you to look at the crop, or for the system to look at the crop and identify if there's an issue with growth 3 days before the human eye would. Now, if that's the case, then that tray would go off to another part of the vertical farm, where it would be given treatment, if possible. And that could be a different light diet, or it could be that actually we need to remove that tray from the system. So that's kind of why I describe it very much like a hospital or a treatment pathway or a growth pathway. In terms of new things that we're developing, we are developing an autonomous robot, which is effectively a tray which you would otherwise put crops on, which will move through the system, so that actually, apart from periodic maintenance where you may need to replace a faulty diode because things break sometimes in vertical farms. It can't be perfect. We're effectively eliminating the need for operators to go into the growing environment entirely. So, and then on the software side, predictive analytics for maintenance, and then as we build up more data, you need a lot of data to obviously deliver on people talk a lot about machine learning and AI, and they just throw the words around very, very, in a very bad way. But the more data that we acquire, we're building data algorithms and integrating AI into our systems.
Excellent. So it's like the plant wellness growing factory or whatever.
Yeah, I think one of the first things we're deploying on the AI side for software is customer support, where the customer support will be aware of specific issues with specific crops. So if, for example, we're building a farm and we don't have somebody sitting on the other side of the world, or they're asleep or something in the customer service department, you can literally just kind of talk to the chatbot and get some simple solutions.
And sympathy for the plant, I hope.
Sympathy to the plant, of course, and the end consumer. Yeah.
And finally, Dr. Martijn, tell us about what your plans are for the agricultural sector and how you're going to make a difference to Saudi Arabia.
First of all, to continue the work on the seed treatment. There are certain seeds that have very hard skulls, that have difficulties germinating, and those are ideal candidates to create these micro cracks and to make them grow faster and better. Secondly, I'm really looking forward to treating irrigation water and to demonstrate the benefits of ultrasonically treated water compared to normal irrigation water, and to be able to quantify, even though the investments are rather low, we're talking about 10,000, maybe $15,000 or euros for a system where we can really treat a huge amount of water, so the capex is very low and the benefits are high. And lastly, the soil treatment. To treat sand, we talked about using this nano clay in combination with ultrasound. I'm convinced that we have an even better solution if we use these different technologies combined.
Thank you. Well, that draws the panel to a close. I'd like you to give our panelists a big hand for coming here today and talking about the topic and taking the time out. Thank you very much. Thank you. And could we do a photograph in the middle of the stage, please? Thank you.
أعزائي الحضور، السلام عليكم ورحمة الله وبركاته. أحييكم في اليوم الثالث للمؤتمر الدولي مستقبل الزراعة في المملكة العربية السعودية. برنامج اليوم سيكون باللغة الإنجليزية لغير المتحدثين بهذه اللغة، فضلاً استخدام الباركود الموجود في الخلف، ثم اختيار اللغة المطلوبة. ستظهر الترجمة على الهاتف. شكراً لكم. Distinguished personalities, ladies and gentlemen, today is the third day's program of the Future of Agriculture International Summit, and I'm honored to extend a warm welcome to all of you. The question of population growth has long been connected with the concern of food security. By 2050, for example, the global population will reach 10 billion people, requiring a 60% increase in food production. In the last years, it has been established that the food systems are increasingly vulnerable due to pressure on natural ecosystems and climate. Today's keynote address will be delivered on climate resilient production as a path to sustainable self-sufficiency by Dr. Pierre Braun, the Director of Climate Resilient Agriculture at Topian, the NEOM Food Company. Dr. Braun oversees the development of sustainable, innovative, and profitable farming systems to support food self-sufficiency at NEOM and food security for the country. Before joining NEOM, Dr. Braun held executive positions in the food industry, including over 10 years as a head of plant science at Nestlé. The keynote address will be very interesting indeed. Ladies and gentlemen, please welcome Dr. Pierre Braun.
Good afternoon, ladies and gentlemen. I'm very honored to be here presenting this keynote address on behalf of Topian, the food company of NEOM. And what is going to be the hope is that we can start presenting in a more practical detail what we are trying to accomplish at NEOM. So, as was just introduced, we were facing more and more difficult situation with agriculture worldwide, with the prevalence of unsustainable practices, which have a damaging effect on our environment, with a very large footprint of agriculture contributing to greenhouse gas emissions in particular. And this creates, together with other factors, global food supply risks. We've talked about the increasing population, but there's also the risk of conflict, the risk of exchanges being hampered. We've seen the global health crisis and its effects. And of particular relevance to this area is the problem of water. And we know that of the fresh water, 70% is used for agriculture. And this is becoming more and more of a problem in areas such as ours and the region, but more and more regions around the world that are suffering from marginalization of the climate and the paucity of water that's associated with it. And then if you look at the consumer side, there is a situation where we have, on the one hand, reducing hunger, which is a very good news, but at the same time, the development of health issues, in particular problems of chronic diseases, metabolic disease, 40% of the population in the US is now suffering of a fatty liver disease, and that's costing a lot of money to society. And what we're trying at NEOM is to modestly address these different aspects, but in an efficient way, trying to leverage innovation and be a test bed for solutions that aim to improve our global food system. So I am the head of the agricultural business unit at Topian, and our ambition is really to develop activities that can be a lighthouse for the rest of the country by testing and making available technologies that can help modernize agriculture in the country, supporting food security in the kingdom, of course, but also self-sufficiency for NEOM, which is a region that's developing and that will harbor a large population in the future. So we want to develop and validate a number of technologies that can help improve productivity, the quality of our produce and our products, and while having a positive environmental impact, in particular with respect to water. Being a company, we are held to financial targets, and so we have to deliver against the volumes that we want to deliver and against the profitability that we want to deliver as well, but all of this sustainably, as I mentioned. And what is also very important in order for our activity to really set a seed that leads to sustainable development is that we contribute to the training of the agricultural workforce and help develop the next generation of farmers that adapts to the modernization of agriculture. There is a favorable context to the development of technology, modernization, new opportunities to develop, is when there is strong market dynamics. We know that imports are still important, so there's opportunities to substitute to imports by producing locally. That's quite significant still for both fruit and vegetable. Production, and I'm going to focus on fruit and vegetable as you've this is really what's going to be the focus of our activities. So fruit and vegetable production remains seasonal largely, and the quality remains inconsistent. And then the production still relies on the unsustainable use of resources, in particular large-scale use of underground water. So we ambition to, together with partners, lead to the production of around 450,000 tons of fruit and vegetable, which corresponds to self-sufficiency for a population of 1 million, and producing fruit and vegetable at a high quality, competitively, in a sustainable way, and doing this being mindful of market dynamics, of the need of consumer, presenting new opportunities, new consumption occasions, more convenience, and all of this keeping in mind that water use has to be reduced, and we think that with new ways of production this can be achieved in a very significant way. So the way we're approaching this, which is quite unique, is that we have the possibility to develop pilot infrastructure, and this is very important for us because what we want to do is to develop alternative solutions and technology packages that can be handed over to our partners so that they can successfully put in place the right combination of cropping systems and crops. And we want to do this by addressing the solutions end-to-end from the production to the marketplace. So we will put in place a number of pilots based on the range of technologies. We will test those technologies. We will make use of digitalization to help optimize. We will identify scalable solutions that not only work in terms of production, but also are suitable for the market. And then we will use these the findings to deploy at scale together with partners this technology, and then feedback the information back in the pilots. So there's going to be a loop where we have the information we get from the pilots. We'll have very sophisticated ways of monitoring what's happening, not only technically, but also in terms of cost of production, in terms of labor use, in terms of also how our partners are able to manage. We'll test the products on the marketplace, and based on the feedback, we'll also be able to adjust everything end to end in terms of what works as a product, what works as a packaging, what works as the total offering to the consumer. So the way we are seeing it is that controlled environment agriculture is going to play a very important role here because of the incredible productivity that can be achieved. And this ranges from relatively low-tech technology, low-tech greenhouses, to high-tech greenhouses, where productivity increases with technology, also water use efficiency, which means that we use a lot less water in high-tech than in low-tech. And the productivity increases with technology, but also does the investment that's necessary. So what's important is to find the sweet spot between the level of investment, the productivity, the quality, so that ultimately the return on investment is worthwhile. We're also going to be involved in open field production, mostly fruit production, where there's still a very large, very good opportunity there. We can contribute, and where the water use efficiency needs also to be addressed. And then we also are looking at vertical farming as a solution, but we're only addressing this in a pilot in our strategy for the time being, until we have really demonstrated that it has its place and its role to play. So for many years we have been talking about what we want to do, but now we have the pleasure to introduce our first structure. This will be opening at the end of November. This is a 4-hectare high-tech greenhouse where we have 4 different sections: an automated lettuce production system. We'll be producing strawberry, we'll be producing vine crops. And each of the sections of 1 hectare is subdivided into 2. Each of these compartments is independently controlled, so we can really try to optimize a number of parameters, not only the crops, but also the conditions, also the different cooling systems that we have in there, so that we can ultimately use this as a model that is, with the help of digitalization, can be simplified to the maximum to offer just the best, but the minimum required to get the highest return on investment. So there's a twin of this greenhouse that is being built also in Tabuk with our partners at Tabuk University. We're very proud to collaborate with them. And this is a structure that will be finished at the end of January. So very happy to share this news with you. I will tell you more about this very soon. So in summary, what we want to do is to contribute here to the improvement of food security, food self-sufficiency by introducing innovative approaches that can be deployed in agriculture. Our production systems, we ambition them to be also useful, not only in the region, but more largely across arid zones that are suffering from the climate crisis. We are really taking a consumer-centric approach, so I work every day with our colleagues in marketing and supply chain to make sure that whatever we do really makes sense on the marketplace, and that we ultimately deliver the quality, the nutrition, all of this sustainably. We leverage this pilot infrastructure I talked to you about, and we are still growing it in the next few years to optimize our production system and to lead to commercial scale-up. What's very important for us is our partners, so we really welcome events like this one, so we can further the links and possibilities of collaboration. We are very looking forward to discussing with you if you're interested in a project, so that we can ultimately have the impact that we desire to help this country and generally the region as a whole. Thank you very much.
I'm going to introduce the first panel of the afternoon. My name is James Morgan. I'm with the Riyadh Exhibitions Company, Again, we're celebrating the 41st year of Saudi agriculture, so we're very proud to be here with you and very honored to have you all with us. So I'm going to ask all the panelists to come up to the stage. As you can see, we've got Dr. Issam Jamia, Mr. Abdul Rahman Ashibu, Mr. Ramadan, and Dr. Ika Hernandez. If you could all come up and take your seats in order of the pictures on the screen, just so I don't get mixed up during the panel discussion, because I haven't met you all. Thank you very much. Hello again, Doctor. Nice to see you again. So what I'm going to ask you to do in the first place is make sure that you're as close to the microphone as possible, like I am right now. Otherwise, we won't be able to hear you. But to start off, I'd like you to each give me 20 to 30 seconds on who you are, where you're from, and why what you do. Okay? Thank you.
Thank you. Thank you, everybody, for giving this opportunity to join this workshop. My name is Issam Jamia. I graduated from King Saud University back in 1983 in chemistry, and I did a master's degree from Manchester University in UK and PhD from Leeds University in UK. I have been with SABIC for almost 35 years now, all in the technology and innovation.
Thank you. Next, please.
Assalamu alaikum. Thank you for having me. My name is Abdul Rahman Ashibu, and I have the privilege of leading a company called Saudi Desert Control in the Kingdom. I started my career in the financial sector before deviating into agri-tech.
Thank you. Mr. Ramadan?
Assalamu alaikum. I'm Mohammed Ramadan. I'm the CEO of Al Yasin Agri. My background is in computer science, but it happened that agribusiness is my family business, so they pull me into agriculture.
Thank you. And Dr. Hernandez?
Good afternoon. First of all, thank you for having me this afternoon. I am a PhD in plant physiology by the University of Barcelona. I've worked for like 15 years in the public research sector, but now, since about 10 years ago, I work at Futrico Bioscience as the head of the molecular biology research unit.
Thank you. Okay, Dr. Sam, I'm going to go to you first, and I'm going to start on food security and the role of pesticides and fertilizers. If you could just do a brief roundup on how that contributes to food security.
Thanks for the question again. And I believe we at SABIC, as a global producer and marketer of agri-nutrients, we take strategic and long-term approach to ensuring sustainability of our products. We always trying to convert the challenges. We understand the challenges the food and agriculture sectors are facing today. We're trying to convert these challenges into opportunities. We leverage our technology and research competencies. SABIC has over 22 technology centers around the globe with over 2,500 scientists. So we leverage these competencies towards developing or exploring opportunities beyond conventional fertilizers, seeking to meet the evolving needs of the growers on the globe. Our solution or our focus is towards having new solutions, not only increasing the crop yield and the quality, but also reducing the harmful emissions and also using less resources. So this fits with the challenges that we are facing and trying to convert them. Today, our portfolio ranges and extends from very general products to very specific. We have things like the first biodegradable control release fertilizers, which is the first of a kind in the world. We have also the uric calcium sulfate is the first of a kind fertilizer, which really using a byproduct material, converting it to a very valuable fertilizer. We also have very unique products other than these two. One of them is the bioenhanced urea, where we take microorganisms and coating our urea, so enhancing the performance and making our product more environmentally friendly.
Thank you. Dr. Hernandez, hearing all that and being a specialist in this field, is there anything you can add in terms of the fertilizer and pesticide research that you've done and the complementarity that you have with what's happening at SABIC?
Yes, actually, I think I was thinking that some of the functionalities he was mentioning are slightly overlapping with what we do. For example, these urea enhancers. We are developing new tools to monitor microbial activities in the soil to try and enhance the use of all these inputs to optimize and thereby somehow reduce the input, or maybe use better what is put in it. So yeah, this is a direction that we are exploring to at Futureco.
And how long is the implementation of this research going to take us? Are we in the very early stages, or are we kind of quite far ahead?
It's, well, we are relying a lot in computer science, as my colleague was mentioning, and it's quite developed. We've been working on it for about 3 years or something like this. It's a kind of a pre-commercial stage. We've done some field tests, and it's working fine. So we are in this sense, we are moving to a kind of more personalized agriculture and personalized inputs for every soil, because in the end, every soil is unique. It may have different needs.
So, Mr. Ramadan, from your point of view, your business is around fertilizers and pesticides. What are your customers? I mean, what are they looking for now? And where's the research in terms of where the customers are and where the research is? Where is there a gap there? Was it a close gap? Is it far away before we implement?
I think our role as a trading company is part of the chain. So producer, researcher, and we are the one who deliver it to the customer. The farmer in the end need a value, and the value is created from seeing results. For a sophisticated solution, the results must be highlighted well and marketed as well, and that's one of our strengths, to have access to the farmer. So in the Research Institute, they do a brilliant experiment and tests for technologies. But some of the technologies works well in the lab environment, but when it come to the farm level, then it's a different story. So what we do is that we are keen to introduce new technologies, and by our strength, we can work first in our field trial, where we have a farmer practice tried in a controlled environment, but it's not a lab, it's a farm. Then we went to the next commercial stage, pre-commercialization, then commercialization. And really we can create demand, and we've got history of moving technologies from the lab to the commercial part with a good success in the kingdom.
So just talking about success, I mean, obviously there's going to be some kind of gap between the commercial farm and the smaller farm holders, and how they implement and the capabilities of those different levels. And how do you educate that customer base about these new technologies?
That's correct. One of the things we highlight always, that we are a technical marketing company, means that we do sales, but we really focus on being ground in farm with our agronomists, where we understand the issue and understand the solution we're providing, where it just fit together, and then the results captured and the value is captured, of course.
Excellent. Now, fertilizers, pesticides, they all end up in the soil, don't they? So this is your role now. I mean, being at Saudi Desert Control, what happens in the soil? What happens in the desert with desert farming?
Okay,
Can you take on this this challenge?
Of course. So I'll give you a little bit of a background of what we do. So we are dedicated to combating desertification and promoting sustainable agriculture. And today, globally, 46% of the lands are at risk of desertification. An area like Saudi Arabia, where it's 80% desert, we face huge challenges, especially having the majority of the kingdom having sandy soils. Through smart technologies such as the technology that we provide soil enhancers that increases the sands, that increases the soil's capacity to hold water, which is very, very important in areas such as Saudi Arabia. Today, the agricultural industry consumes 70% of all fresh and deep well water. And we are on a mission to reduce that drastically.
And how does grey water fit into that? Instead of just fresh water.
That is a question that I have to address to my technical team. I'm happy to answer it.
Okay.
We do not use grey water. We use a product called liquid natural clay. And it's basically a mixture of clay, water, and natural minerals. When applied, this creates a bond between soil particles and increases the capability of the soil to actually hold water. So you can maintain or increase your production while reducing your water usage by 50%, which is a big deal in areas like Saudi Arabia.
And then what are the impacts of the new innovations in fertilizers and pesticides on your desert environment?
Honestly, by adopting such innovations, you are able to increase production. So this impacts food security directly. And then by doing so, you can also reduce waste and conserve natural resources such as fertilizers, such as water, without affecting your production or your yields.
And are you seeing yields going up through this approach?
Yes. And I'll take two examples of live projects that we have performed. One on date palms, which is the #1 crop in the kingdom. We managed to reduce irrigation by 46% by treating the soil. So we reduced irrigation by 46%, and the positive impact affected yield. So we saw an increase in fruit quality and also in yield itself by up to 16%.
Wow.
This solution is long-lasting. We treat once and it lasts for 5 years. So it's durable, scalable, and actually very affordable.
That's excellent. Thank you.
Yeah.
You heard it here first, guys. Okay, and ladies, sorry. No, that's excellent results. Excellent. Okay, so we're going to switch back to SABIC and the doctor here, who I've met a couple of times now. The SABIC agri-nutrients contribution to these solutions in Saudi Arabia. So we've talked a bit about implementation here. How are you viewing that from the research onto the land and in terms of yields, sustainability, etc.?
Excellent. I think we are working in many dimensions today. One of the dimensions is we have a project with Aramco, a big project called Carbon Hub, where we are viralizing the methane to make turquoise hydrogen and solid carbon. We're trying to modify this solid carbon to be a soil amendment, and we have a good progress in this project. We are aiming to reduce water consumption by more than 90%, and we're doing a lot of studies on this. We have a consortium, including Rice University, Berkeley University, SABIC, and Aramco. This is one of the solutions we are trying to bring to the kingdom. There are many solutions that we have crop-specific products. We have, as I said, the first biodegradable control release urea. This is the first control release urea which used a biodegradable polymer. This is a unique product. It should be 80% degraded within 2 years. And we have a release pattern can go up to 8 months. So this is a very unique product that we are bringing to the market very soon. And we have many solutions. I think the time is not enough to cover them all, but we are working on all dimensions. We are working on compounding fertilizer. We're working on enhancing our urea fertilizers to last long, and also in soil amendments and other activities.
So you have a very large research wing, and how many people are involved in this?
SABIC in total has over 2,500 scientists working around the globe. We have over 22 research centers, technology and innovation centers. We have 3 in Saudi Arabia, 1 in Riyadh, actually 2 in Riyadh, but 1 will be closed very soon. 1 in Jubail and 1 in King Abdullah University in Seoul. We have 5 technology centers in US. We have 1 in Germany, 1 in Netherlands, 2 in Netherlands, 1 in Japan, 1 in Korea. So in India, we have 1 in Bangalore, we have 1 in Shanghai, China. So we have a very good network around the world, and we're trying to use the resources. We are working on a sort of center of excellences, so every technology center is focusing on certain activities and applications.
Excellent, excellent. That's phenomenal amount of coverage. Abdul Rahman, the commitment to more environmentally sustainable agriculture, and you talked about reducing irrigation. There's some impressive figures there, without affecting productivity. What about flavor? I mean, I'm a chef. I love to cook. You know, what's the flavor going to be like if there's less water, more fertilizer?
We haven't seen any change in flavor. If anything, all the impact was actually very positive.
Okay.
So we actually saw an enhancement in fruit quality.
Because what I'm seeing in the kingdom is, you know, the taste and the demand for restaurants and good quality products and everything is fantastic. You know.
Yes.
The amount of new restaurants and different concepts, and they all need your food. You know, that's part of food security, is that lifestyle equation as well. So you're telling us flavors enhanced?
Yes, we were telling you.
Okay, is everybody happy about that? Are we happy about enhanced flavor? Thank you.
You're welcome.
Okay. Masal Ramadan, the qualities of fertilizers that you bringing in to the market. What about environmental protection? Do you test these, or, you know, in terms of specifications, are they cleared through anybody? Is there any worry about bringing in imported pesticides or fertilizers?
The protection of environment is extremely important. Even sometimes that the commercial part could harm the environment, which I don't think is seen here in Saudi, because we've got a strong Ministry of Agriculture responsible. MIWA is having a very strong regulation on what kind of fertilizer is allowed and what kind is not allowed. Every kind of fertilizer is actually checked at the borders before entering. So there is a lot of quality checking before it reach the consumer of fertilizer. Now I want to shift the question a little bit different. Is there a solution for being more sustainable when it comes to fertilizer and pesticide? And I say yes, there is. I mean, there is a lot of work on having control release fertilizer, smaller fertilizer usage per area square meter, using fertilizer that having less leaching. And those are important because instead of using, let's say, 1 ton of fertilizer, you can use 200 kilo and you will have same results or even better. And that's one of the things we really work on it. Sometimes we face difficulty with the regulators because some technologies per the book is not allowed because, for example, it got less fertilizer than normal. Or, for example, some fertilizer got the bacteria in it. So those solutions or alternative in the end make farmer use less fertilizer, so less CO2 footprint, and with the same results or even better. And if you use less fertilizer in land, you just save it for longer because every time you add conventional fertilizer, you're basically adding more salts. And our soil is salty already. Our water is salty already. So it's better for the soil to have less fertilizer to keep it live longer, having more life into it with the bacteria and so. So yes, answering your solution, we like to have more sustainable fertilizer, and currently we have some, and we are keen to have even more in our portfolio.
Thank you. And Dr. Hernandez, your research and a feasible alternative to chemical pesticides, where's your research on that? Just going on from...
the chemical fertilizers and pesticides is a field that we don't work with because it's within the philosophy of Futureco to go only for a sector of environmentally friendly products. That doesn't mean that chemical fertilizers or pesticides are useless or nobody has to use them because, of course, they are useful. But in the end, is what my colleague was saying. Sometimes you are providing to the soil something that is not needed or in excess, or perhaps just modifying the composition of it is better. You're providing a lot of nitrogen, but perhaps what you're needing is phosphorus. And you don't need to apply exactly the same to all plots. So this is a bit our know-how. We are a small company, like 50, 60 people, but we cover all the aspects from the supply chain. We design the new fertilizers, the biological fertilizers. We develop them, we commercialize them, and we manufacture them. So we cover all the gaps. Sometimes directly, sometimes with partners, like here in Saudi Arabia with our distributor, New Habitat trading company. But yeah, I think it's more about analyzing or seeing or knowing what is needed and then applying it, not just policies to apply the same to everywhere, and therefore you're wasting resources, you are ruining your soil, which is in the end the main asset you have, and in the end you're compromising the future. Which,
and as part of your Futureco Bioscience, what other developments do you have in the pipeline besides the fertilizer side of things? Do you have other biological?
Yeah, we're working now with. We are developing a new platform called Genomat for personalized agriculture, and also we are opening new lines of research that are about to come with some new products about microbial metabolites for biological control, and also RNA interference. For now, it's quite, let's say, perhaps too innovative field because it's got a lot of hurdles, formulations, stabilities, and so on. But it's extremely environmentally friendly and extremely effective when you find the right way to use it. But as you were saying before, this needs proper technical training and knowledge about how to use these products.
Yeah. I suppose with innovation, we all have to learn how to use it. I remember when I had my first smartphone, I was all fingers. But I'm gonna go back to Mr. Ramadan, and your slogan at your company is "We plant today for a fruitful tomorrow," and that slogan. How have you contributed to food security through that kind of marketing slogan over the last few years? I mean, education has been one of them. Tell us what else you've been doing.
I mean, if a future does not, I mean, if farmers does not grow in the future, we are out of business. So it's very linked for our business sustainability that farmers continue. And not only continue, but it must be profitable for them. And they can grow as well. So whatever we bring must be aligned with this. So we always seek the 3 wins where the farmer must win of what we provide. We as a company, owners and employees win of it. And of course, suppliers where we bring products must be winning. Then it's sustainable growth. Again, as my colleagues mentioned, IPM, biological, less pesticide, lower PHI, those are really important, and it's very aligned with the 2030 vision. So we are keen and we are working and continually testing things that really works in the Saudi environment and help future generation to grow in Saudi.
Thank you. And Abdul Rahman, your smart farming solutions, what's the role agriculture will play in economic diversification, especially in the desert context?
Agriculture plays a huge role in economic diversification. Today, agriculture agriculture contributes approximately 2.3% of the Saudi total GDP. And by applying smart agricultural solutions, whether it's our technology or other technologies that are in the market or the ones that are still coming, you can increase the output from agriculture while still preserving natural resources. So you would be reducing the input and increasing the outputs. This contributes directly to food security, and it also impacts the economy by job creation because you're applying new technologies and adopting, you get more people into the market, you impact the imports and exports, and you preserve natural resources. This is a very important industry for the kingdom. And if we position ourselves as leaders in smart agricultures, we can increase the industry's contribution to GDP.
I think it's, maybe I've misread something, but I think you, the kingdom exporting dates because you're quite self-sufficient in that.
Yes.
So that's a big win for the export market.
Yes, definitely. And you also have certain crops that you are limited, or you are, let's say you're not allowed to produce, given their high water usage or stuff like if you take alfalfa, for example, which is a very important crop, whereas there's limitations on alfalfa production because it consumes a lot of water. By adopting smart technology which significantly reduces the water needed to grow such crop, the kingdom might ease restrictions on growing such crop. And this can be applied to different kinds of crops that have not been grown in the kingdom before and might open doors to actually grow here.
So what kind of applications in terms of smart farming, say for alfalfa, you're talking about water reduction, so give us an example of the kind of smart applications.
We've applied our soil enhancement technology to alfalfa crop. And by treating the soil and enhancing its capabilities of retaining water and natural resources, we managed to reduce the water requirement by 55%, and in turn reduce the energy involved in growing it, the use of the need for fertilizer reduced by 20%, and we also saw an impact in yield, both in quantity and in the quality of protein in alfalfa. And this is by adopting one solution that we are offering. And the market is filled with smart solutions.
Excellent.
Yeah.
Thank you.
You're welcome.
And Dr. Sam, environmental protection in agriculture, and how do you predict or project the use of pesticides, and how do you marry up environmental protection and pesticides in the future? Obviously, you're doing a lot of research in this area.
I think there will be, I think, I can divide them into two categories, one towards application and the other category is technology. So from application perspective, I would assume that there will be more popularity for systems like digital farming, precision farming, where really precise amounts of fertilizers and pesticides are targeting the right plant, the right location. I think from that perspective, more efficiency of utilization of fertilizers and pesticides from application perspective. This is one category. And the other category is about developing new technologies. And here we're talking about also making the pesticides and fertilizers more efficient, producing more out of less, and higher quality and higher quantity.
So we're going to close this panel soon, but I just want to get some ideas from each of you, kind of crystal ball of the future. I'm going to go to Dr. Hernandez first. You're sitting in Barcelona, what a lovely place, and now you're visiting Saudi Arabia. How are your technologies going to contribute to food security in Saudi Arabia in the immediate future? What's in it for us here in Saudi Arabia of what you're doing in Barcelona?
Well, I live from quite far away, but with this climate change, Spain is becoming more like Saudi Arabia, very, very quickly actually. And we have already been developing some products that are perfectly compatible with Saudi Arabia agriculture. For example, products to enhance crop performance against drought stress and salt stress. These are based on microorganisms. Also to reduce the water use. So you can reduce about 50% with some of our products, watering, particularly in alfalfa too. But yeah, we face more or less the same problems, of course not all over the world, but particularly in Spain we do. Futureco sells its products all over the world, and this includes this Middle East, but also Africa, Australia, which have common problems. And coming back to what my colleague was saying before, when you come from like low-tech agriculture and you go to high-tech solutions, there's a transition there. So you need to go with the farmer, teach him how to use these technologies and show him the advantages, because in the end, once your business is already running, you can always improve it, make it more sustainable, and it's a starting point, but then you go refining your performance. And this is, I think, a part where Futureco can contribute in Saudi Arabia.
Mr. Ramadan, capacity building, capability building in terms of smaller rural farmers rather than large companies. Do you see challenges there? I mean, how's your company dealing with that?
Yes, with the small farmers, we see quite a lot of challenges because, first of all, the economy of scale is not always there. In addition, adapting new technology could be harder for smaller farms. But at the same time, we are in a very revolving world. So smartphone, as you mentioned, was something unique. Now it's very common. So previously when we say medtech is changing now. Now medtech is plastic tunnel. 30 years ago, medtech was using the old irrigation system. So I believe with the revolving technology, even smaller farmer will keep on having a way for keeping their farm living.
Good, thank you very much. And Abdurrahman, from your point of view of the challenges that are ahead of you in the future, what do you see the challenges and how might you deal with those?
One of the challenges is educating people, especially those farms. If you take farms, for example, that have been doing things in the same traditional way for 30 years, convincing them to adopt a new way of doing things when it's been working for them in the past. Sometimes it's difficult, but it's a very important mission. Water is a scarce resource, and with our ambitious plan to grow 10 billion, it's going to keep becoming more and more scarce. That is the biggest challenge, but we do see traction in people actually adopting the technology. There is traction with the government and actually validating and adopting such technology. So the future is bright, and we look forward to it.
Good. And Dr. Sam, are you of the same mind that the adoption of new technologies can sometimes be challenging?
We here in Saudi Arabia are facing more challenges. Definitely resources is one. Water scarcity is a major challenge for Saudi. And the other angle is also carbon farming. I think carbon farming is something is coming in the pipeline, and we need to be prepared for with the VCM, the value carbon market that is coming, and carbon credits for all farmers. I think that would represent a major challenge for all farmers in Saudi Arabia, how they can improve their environmental activities, reducing their harmful emissions, better utilization of their resources and others. And I think that is a major challenge will face all the farmers in the coming and very soon.
So I'm not going to get into the livestock arena right now, but okay. I can see that's going to be a huge challenge as well, isn't it? Yeah. I would like everybody to thank this excellent panel today. Thank you very much. And
thank you for all the speakers for their valuable insight. Distinguished guests, I'm delighted to introduce to you a case study on innovation for sustainable food security, a very interesting topic presented by Professor Dr. Mark Tester. Professor Tester is a professor on plant science at King Abdullah University of Science and Technology. He's also a chair of the Center of Excellency for Sustainable Food Security. This case study is an exceptional occasion for knowledge sharing. As we know, the aim of the research program conducted by Professor Tester is to elucidate the molecular genetic mechanisms that enable certain plants to thrive in suboptimal conditions. I will not tell you more. Please, ladies and gentlemen, let us welcome on the stage Professor Tester.
Thank you very much. It's an honor to be here today and have a chance to introduce some of what we're trying to do and some of the roles for innovation in agriculture. I mean, we have a very serious situation here in the Middle East where agriculture is critically limited by water and heat, and climate change is likely to make this situation more challenging. But, call me a techno-optimist, but there are many technologies which we can deploy to help production, especially in controlled environment conditions. This is a global problem as well, and Saudi Arabia is an excellent platform for developing technologies and rolling them out to the rest of the world as the effects of climate change bite, not just in Spain, but in many areas in the world. Agriculture is, I argue, the most environmentally impactful of all human activities, using half of all land, 3/4 of all fresh water, and even more in this region, and is the second largest emitter of greenhouse gases globally. And there are going to be significant ongoing pressures on this system due to the rise in population, the ongoing diversion of produce for biofuels, and climate change. So the challenges are huge, but fortunately, so too are the opportunities. And technology does provide many valuable opportunities to address the challenges we are facing. Technologies can help with education and training. They can help us teach people and help people manage their personal nutrition. We can help use technologies to help people, consumers, reduce waste. And of course, we can use technology to help farmers do better production processes, just using the processes that they're using at the moment, but doing this better, straight education and training. But technologies can also, of course, help with innovation to help us, for example, reduce loss by improving the food chain, and of course also to improve production in both open fields and controlled environment systems. Some of these technologies include information technologies, AI, ML, that is all the rage this year. The rage last year, remember, was IoT, where we're able to have sensors and gather huge data sets and use that to inform decision making. Computer vision is going to be increasingly important over the coming years. Robotics is, of course, very difficult, but really coming along very, very well. Engineering is perhaps considered often a traditional science, but it is revolutionizing in many areas of engineering and material science. Remember nanotechnology, that was fashionable about 3 years ago, I reckon. This is still making huge impacts in a whole range of human endeavors, including in agriculture. And of course, there's also the biotechnologies. We can use genomics and genetics, which I consider to be turbocharging traditional breeding and giving us opportunities to do things we have never been able to do before, like get hold of wild plants that are out there and turning them into crops much more rapidly that are useful for us. Gene editing and genetic modification, whoa, that's still an area of controversy, but it still provides us with massive power and massive opportunities. And I've written there phenotyping, computer vision, machine learning, robotics, all of these can help us characterize the way plants grow and the way they respond to their environment in more automated, faster, cheaper ways. And this can help revolutionize crop improvement. So this is just a matrix of different areas, different technologies that we can roll out. I just put it up by way of illustration. We have the different segments of the food sector. We have time across from now to after 2030. And it gives you can cherry pick that yourself for a few seconds and look at different areas of your personal interest. We've got many technologies we can roll out now. We've got many which are soon to come, or which really are still around now, but will become increasingly economically viable over the next 5 years. And then, of course, there's the more blue sky areas of activities, which are really the purview of still research and development. We still need research and development at that basic level for the innovations to be delivered in the future. I'd just like to make one point because it's important to consider when we're thinking of where to direct our technologies. There's a big confusion often between food security and food self-sufficiency, where food self-sufficiency is often considered to give us food security. This only goes so far. We should only be producing trying to achieve self-sufficiency within the kingdom, we should only be producing locally what really makes sense. And this, I'm talking about what makes sense technically, environmentally, and as a business. When we have perishables, food that's got a very short shelf life, it makes more sense to be producing that locally because it is expensive to refrigerate and transport, has a huge environmental footprint refrigerating and transporting. And this is where I see a very strong case in Kingdom for increasing the production in controlled environment systems to produce fresh fruits and vegetables with a reduced environmental footprint, in particular, critically for this country, this region, a reduced water footprint. And then what we do is import what we cannot produce locally using sources that are as sustainable as possible. And again, we can use technologies for tracking, for sourcing where we are buying our grains in particular, things which have got a long shelf life, which can be transported non-refrigerated by surface and can be bulk handled. But that's sort of just a side comment, but it does help us, I think, focus our minds in particular on controlled environments. Now, there are many pathways for delivery. We can use startups, we can use government agencies, we can use the Giga projects, intergovernmental agencies. Education, training and outreach is an often undervalued pathway for really strong input. And of course, we can have contributions for policy. But all of these pathways of delivery are difficult. And for me, there's often a gap. There's a gap between innovation and there's a gap between that innovation and between the true delivery. We really are struggling often in that area of translation between discovery and delivery. And I think this requires development, and this is the aim of the centre that we launched earlier in this Saudi agriculture event. The minister kindly launched our new centre that I'm the director of, where our aim is to develop and deliver technology-based solutions to try to maximise sustainable food production and minimise the negative impacts of food production in arid environments. We need to align these with, of course, Vision 2030 and the RDIA activities. And we're now 3 months old, or just over 3 months old. We have 30 faculty from all the divisions of KAUST. We've got many letters of support from many stakeholders across the kingdom. Earlier in this, with the minister, we signed an MOU with Dutch Greenhouse Delta. That is not an accident. That was the first action that we initiated, and that's because, of course, we want an emphasis on controlled environment agriculture. We're doing translational projects within the centre, within the university. We're supporting PhD students, but we also already have 6 projects with in-kingdom partners. And I really want to announce that what we're going to do next is have more projects where we reach out to you. You've got problems. We may or may not have solutions, but if we do, we're going to contribute money to a joint research project. And we want to be able to help you help the projects and help the innovations and, most importantly, the delivery of innovations. And we also have, importantly, an edible education program where we're trying to reconnect school children with the source of their food, grow food in their environments, and try to do so as sustainably as possible. And of course, that's also something where I'd invite you to be sponsoring. It gives you it's a good feel story, and of course ticks some of your ESG boxes as well. We're already delivering in KAUST, we're already delivering in multiple ways, and I just want to give you 2 examples of technologies that are already being delivered through the startup pathway. KAUST is already started a strong company. It was originally called Red Sea Farms. I'm one of the co-founders, so this is a biased view, of course. No, I'm trying to give you the scientific objective facts. But what we have here is a company started as Red Sea Farms. It's also called Red Sea as the parent company now, and primary activity is through the primary division of the company called IRIS. And through IRIS, we're working to deliver a couple of really significant technologies. One here is rootstocks, which have been developed from my own research over the last decade. And I'm very proud actually to mention Dr. Abdulaziz, with whom we have been collaborating with some of this work. We published a patent just 3 weeks ago with the process, how we used new types of genetics that we developed to try to make these ultra strong rootstocks, which are leading to huge increases in yield in open field, in particular in open field tomatoes. And this is doing this because we've developed rootstocks which have got roots that are extraordinary, truly extraordinary roots. And these are helping us maintain, well, increase yields and maintain yields in the face of a range of environmental stresses, such as heat, salt, and drought. Another technology which was developed by Professor Deria Baran, who's a material scientist. She developed a nanoparticle which is absorbing in the near infrared, yet allowing very high rates of transmission in the visible. This leads to a reduction in the heat load in the greenhouse. It leads to reduction in energy consumption, water consumption in the greenhouse. It increases yield because the plants are happier, and it increases profitability per square metre, which makes the farmer happier as well. So we have happy plants and happy farmers using a KAUST technology that's being delivered through my company. You can go and have a look. We've got a stall in Hall 5. 5255 is the stall, and that's a picture of it that I took yesterday. So it's another example of a KAUST technology that we're trying to deliver into the kingdom, and we really want to do this a lot more, because the kingdom desperately needs more innovations to be delivered. The planet needs more innovations to be delivered. The core business of universities is innovation in a range of areas. And our job now is to facilitate the delivery of these innovations from the lab to the kingdom. We need together to navigate these valleys of death and help us try to make agriculture in the kingdom more sustainable. Thank you all very much.
We're now ready for the next session, and we are going to be talking about precision agriculture, and we have a fantastic panel with us. I'm going to ask the panelists to please come up to the stage and take a seat in order according to your photographs, please. Panelists, can I invite you onto the stage, please? Thank you. Okay, I would like to ask each of you to introduce yourself and tell me a little bit about your company or your organization and where you're from, where you're based. Thank you very much. Dr. Orn, if you could go first, please.
Thank you very much. I'm a soil scientist. I have experience in the UAE for 15 years. My journey is transition from Thailand and then moved to the UAE for 13 years before I moved to Saudi Arabia, and I'm based here with the company called Saudi Desert Control. Yep. My passion is about bringing the practical and sustainable solution to be able to implement and solve the challenges that happen in the country. Thank you.
Thank you. And Mr. Jorik Bremer?
Assalamu alaikum, and thank you for the invitation to participate in the panel today. My name is Jorik Bremer. I'm a director at the company Hudson River Biotechnology. And prior to working at Hudson River, I was involved in various other innovative companies, including larger ones like Microsoft in the Netherlands. And for the last 3 years, I've been involved in agriculture, and most currently, as said, at Hudson River, where we do gene editing, which is a rather important field of innovation in the industry.
Thank you. And Dr. Mo?
Thank you very much. So I am an agronomic engineer. I am doctor in agronomy. I have more than 22 years experience with agriculture and agribusiness in many countries, France, Spain, Morocco, Tunisia, and since 2 years I starting a new experience in Saudi Arabia. I was director of agriculture in NADEC, and now I am the technical director of a company that is is a laboratory and consultancy in agriculture, laboratory of analysis in agriculture, soil, water, pesticide, leaves, and giving consultancy of technical for agriculture project. Thank you very much.
Thank you. And Mrs. Labedi.
Hello, thank you. I am sorry, I will speak Arabic because...
Sorry, could you go closer to the microphone? Thank you.
I am sorry, I will speak Arabic because my English is not very good.
That's okay, yeah. If anybody wants the translation from Arabic to English, what you can do is you can use one of these QR codes. Can you put the QR code slide up, please? AV? AV?
Yes.
Hello? Can you put the QR code slide up, please? If you want to translate from Arabic to English, you'll be able to see the text on your phone or any other language, including Chinese, French, whatever. We have 57 languages. So you can get Mrs. Abedi's translation. Thank you very much. Could we go back to the session slide, please? It's back to the session slide. Thank you. Okay. Well, if you would like to introduce yourself, please. Thank you.
Thank you very much. أنا أمل لبيدي مديرة منطقة في شركة سوليم. سوليم هي شركة فرنسوية. نقدم روحي أنا قبل سوليم. أنا نشتغل في مديرة منطقة في الإيريجيشن يعني في السقي. صار لي 20 سنة نشتغل في السقي. اليوم نشتغل عند سوليم. احنا شركة فرنسوية موجودين في مونبلييه. نصنعوا الكنترولر للإيريجيشن يعني الكنترولر اللي يتحكم في السقي الآلي. صار لنا 40 سنة من اللي نصنعوا في المبرمج للسقي الآلي. عنا 40 سنة خبرة وموجودين في 29 دولة في العالم. موجودين في كامل أوروبا، دول أوروبا، موجودين في أفريقيا. عنا سنة من اللي بدينا في الشرق الأوسط، واليوم أنا عندي الشرف أني نمثل الشركة هذه في السعودية.
Okay.
Thank you.
I'm going to have a bit of a problem with you today because my phone is not connecting to the translation device. So I'll have to ask my questions in English to you if that's okay. And then you speak Arabic. Sorry, there's been a misunderstanding with the translation here from the organizer. So let's just carry on. Dr. Orn, please. Can you tell the audience on the challenges of agricultural soil in the desert in general in Saudi Arabia that you have been researching at Desert Control?
Yep. Okay. The challenges, I believe everyone in the country and in this room is noticed that the soil in the country is very low ability to retain water and nutrient. That's one of the main challenges because we use soil for production. Second is low organic matter in the soil, and also this causes the fluctuation of the temperature, which is cause the lack of ability for plant to be able to survive, or we need to support a lot of irrigation requirement for them to grow. And now another big hurdle challenges is the water scarcity. Before in Saudi Arabia, you have plenty of groundwater. However, at this moment, many farms and growers is closed their own operation is because of lack of water. Now the challenges that happen is the knowledge gap that I have seen. The knowledge gap is our ability to adopt a new technology. And however, I believe and see that the difference in terms of the knowledge gap is closing. Especially today, I'm really hopeful that I be able to see a lot of innovative technology that available in the country or will be entering in the country to be able to improve agricultural production. Yep.
So, just going back to the implementations, what are the main challenges there?
Okay. Allow me to explain a little bit. I'm work with the company called Saudi Desert Control. Saudi Desert Control is the licensed operator of the technology that has been invented by a company called Desert Control from Norway. The technology is called liquid natural clay technology. What it does is that we liquefy the natural mineral into a nano and micro particle. When we implement it into the soil, especially the coarse soil and the sandy soil, it does help improve the structure of the soil by balancing the small pore and the big pore in the soil and allow soil to be able to retain water. One is retain water, is also help retain nutrient. With that in mind, it means that water saving of the water and also fertilizer. And the previous question is about the flavor. It's also enhancing the flavor, and we can work with several types of water. Potable water, sweet water, and sewage water, or even a high salinity water, because the technology is how build the buffer in the soil. There's a lot in detail that I'm very happy to explain. We have a stand at hall number 5, stand 320. Yeah.
Okay, great. Mrs. Labedi, we were just talking about water, so let's move on to irrigation. And tell us a bit about Solem's applications for irrigation.
Oui, je suis en train de lire.
Sorry, I think we're losing something in translation.
It's clear.
Aren't we?
احنا شركة سوليم احنا شركة سوليم نصنع المبرمجات للإيريغاسيون. فالمبرمج في الإيريغاسيون هو اللي يتحكم في الإلكتريكال فالف، يفتح ويغلق الإلكتريكال فالف حسب الوقت اللي احنا نعطيه له باش يعطي الكمية المعينة للماء، يعني للنبتة في الوقت اللي نحبوا عليه. المبرمج هذا نعملوا له البرمجه نتاعو عبر الابليكيشن ولا عبر اللابتوب، من غير ما نبدو موجودين على عين المكان، نجموا نتحكموا فيها عن بعد عن طريق اللابتوب ولا عن طريق الابليكيشن زي ما قلت مثل ما قلت. ويبدا والمبرمج نتاعنا هو كونيكتي فيه شريحه 3 4G وكونيكتي يعني مش مستحقين للإلكتريسيتي، مش مستحقين الباور ومش مستحقين الكابل يعني الوايرلس، هو وايرلس فيشتغل ببطارية 9 فولت ونعملوا له البرمجة عن بعد.
And are you using ground-based sensors to measure the irrigation cycles?
المبرمج متاعنا يشتغل بالبطارية 9 فولت، يعني 9 فولت، وهو نعملوا له الكونكشن على جيت واي اللي هي جيت واي عن بعد عن طريق الشريحة اللي موجودة في وسطها 3 أو 4G.
Thank you very much. So just continuing on from the kind of sensor technology, IoT, etc. Dr. Benamou, in terms of robotics, drones, etc., what are the main applications in smart agriculture?
Okay, thank you very much. So, as we know, all that in 2050, the world population will maybe 30% as we are today. We will reach 9 billion. So agriculture and nutrition. This is data of the FAO, and agriculture have to produce 60% more that we are producing today of foods. The problem that we are many challenges. They are climate change that affect water scarcity. There is less land available for agriculture. There is no available manpower. So for this reason, using and artificial intelligence, Internet of Things, sensors, as Amal mentioned, this is an example of to control irrigation. Also robotics and drones. I will give you some example of the necessity and how will help to increase yield and also reduce the consumption of resources. For example, if we take from the decision how to plant, artificial intelligence consists of analyzing big data. For example, data from weather, from soils, and this will help farmers to take the good decision what crops can be in this kind of condition. After that, farmer can use robotics for planting, for weeding, for harvesting also. This is also something today maybe is an option, but I think that in few years will be a necessity because, as I said, there is lack of manpower. I was lived in Europe, and there is lack of manpower. There is a very high cost of manpower also, and robotic can give precision of the application of pesticide, irrigation, fertilizer. So this can help farmer to only treat and only what it's need. So they will reduce cost of pesticide, for example, and this can have a good effect on environment, positive. Also, we can use drones or Internet of Things like sensors. Today, sensor in open field, in greenhouses, can help farmer to control irrigation with giving plant only what it needs. The sensor can help for analyzing the moisture of, for example, of soil, the salinity of soil in different depth, and it can control irrigation. So plant will have, for example, in the condition of the kingdom, there is scarcity of water and all the Middle East. So sensor can help reducing water resources losses. Also, in harvesting, as I said, robot can help using very special robot that can recognize the color to be of the fruit, and it can detect with the program if the fruit are ready to be harvested or not. Also, after harvesting, in post-harvest, there is using IT, using a sensor to detect, for example, during transport, if there is problem during the transportation, especially when we speak about perishable products. There is any change of temperature can cause very big losses. So sensor can give alert instantly to the producer, to the farmer, that they have a problem of during transportation.
Lovely. So you've described most of the value chain, but I think I'm going to go to Mr. Bremer to go with the plants themselves and gene editing, and what is so good about gene editing in the context of Saudi Arabia and food security? What's going to make the difference to the environment that we have here, the heat, the water scarcity? How is gene editing going to get over that challenge?
Yeah, so in order to answer that question, I think it would be good to go a little bit back in time. So gene editing and CRISPR as a technology first came about more or less around 2012 in a highly academic setting. And since then it's been a scientific field which has really progressed in a very rapid pace globally, I would say. So our company, Hudson River Biotechnology, is a commercial company. And what we do is we enable other organizations, institutes, commercial companies, and even countries to include this new revolutionary technology into their breeding pipeline. CRISPR and gene editing is a technology where you use enzymes basically to go into the genomics of a crop, regardless which crop it is, and change certain parts of the crop. And at Hudson River Biotechnology, we use a transgene-free approach. So there's no foreign DNA included, which is very important also from a regulatory perspective. So what we've seen in different parts of the world is that there's different regulations. And most recently in Europe, in February of this year, the European Parliament has now voted in favor of deregulating this new revolutionary technology to be approved. And I think this is a crucial moment in history which we're witnessing, where Europe will open up in that sense. And many countries, and that's where I come to the kingdom as well, are looking at Europe and want to follow suit basically in terms of regulation. I think there's one more important thing here to mention, and that's there's a big difference between the scientific world doing research on CRISPR and gene editing on the one hand, and applying it in a commercial setting and creating products which can be brought to the market on the other. Because using this technology is given within a field of a lot of patents and intellectual property. So as an organization or a country, you will also need to navigate that part. And I think given our extensive experience in that field, we're well positioned to help the kingdom to include this new technology going forward.
So to implement the technology in the kingdom, do you need the deregulation in Europe in order to export that product?
Not necessarily so, but what we do see is that Europe is very important for many companies and countries in terms of the pace in which things get deregulated. So I think what's happening now in Europe will lead the way also for the region here in terms of what's possible. And as I said, it's a rather complex matter, not only on the regulatory part, but also on the intellectual property part. And a third pillar there would be, of course, on the scientific part. There's many ways to go about gene editing, and the way that Hudson River Biotechnology has gone at it for the past almost 10 years has always been a transgene-free approach, where we use single cell regeneration as a starting pillar in order to do the editing.
Excellent, thank you. Dr. Orn, as a soil expert, transforming soil in an arid environment, how does that work? I mean, what's the science behind that?
Okay, let's start this. Because we believe that transforming arid soil into fertile soil is possible, because we have done it before with the background of research and development of 12 years and commercialization in 3 countries, in the USA, in United Arab Emirates, and in Saudi Arabia. With the technology that we introducing to Saudi Arabia as called liquid natural clay. The science behind is that the intellectual property that we be able to split the clay platelet into nano and micro particle, which is allow us to add the particle that is missing in the sand of Saudi Arabia, which is a natural mineral and the clay particle. And with that is allow water to be able to retain in the soil. Water is the source of life. When you try to transform the desert soil, the first rule is to be able to maintain water. Second process is to be able to create a stable structure of the soil. I believe that the combination of liquid natural clay with organic matter is going to help us to be able to transform the soil of Saudi Arabia from sand to a fertile soil. Yeah.
That'd be amazing. So green Saudi Arabia everywhere, is that what you're talking about?
Okay, let's talk about this topic because I'm a ecological person and I believe that desert should be protected because that's a natural value of environment. However, we are working to combat desertification, push back the area that is turned from the fertile area into desert. We would like to support the initiative of the country to green the city, and we would like to help transform the area which is going to use for tourism such as golf course, sporting field, to be able to balance the water requirement. Water is scarce in this country.
Thank you very much. Yes. Mr. Bremer, more about sustainability and how the gene editing can make things more efficient and sustainable and less of environmental impact. What is Hudson River doing on this area?
Yeah, so far our company has worked on 13 different crops and 40 plus commercial varieties in different categories. So those include vegetables, row crops, but also ornamentals. And if you look at the kind of traits which we've been working on for these different crops, I would say they are categorized in 3 different categories. So one category is the agronomic traits. So those would be the traits where you would edit certain genes to, for instance, create bigger biomass or larger stems, or all kinds of agronomic traits which are relevant for yield-related aspects. The second category is an important one also for the kingdom, and that has to do with biotic and abiotic traits. So you can think of drought resistance, salinity stress, pests, those kinds of problems, which can be changed in the genetics to deal with that. And the third category of traits, which we've been working on, are consumer-facing traits. So those would be traits in the line of sweetness of certain crops or aromics, or the increase of shelf life, for instance, which all, of course, in the end have to do with sustainability as well.
Excellent. And Dr. Villamor, this diversification question and adapting new cultures from various regions in the world. The flowers exports from Saudi Arabia is a big thing from Taif area, and with your company in particular, what are you seeing in terms of diversification? For example, we've seen flowers, we've seen other crops. People are growing alfalfa, we heard in the previous. I think that was part of your colleagues' comments as well.
Yeah.
So where are we going with that?
Yes. Yes, I think that it's a good potential to develop flower, but not only for local market, but also for export. There is some challenge However, for example, as a laboratory, we interested lot of testing pesticide. If we see for the destination is exportation, pesticide is very important to be controlled. Also, skills, another challenge, variety to be introduced have to be adapted to local condition as high temperature, scarcity of water, long shelf life is important also. Logistic should be also taken on consideration.
So, aside from the logistics side, what role is technology like AI and those kinds of things playing in this diversification equation?
Yes, for artificial intelligence, no? Yes, for the transport, it is important to get, as I mentioned in the example, real-time condition during the transport. When we spoke about flour should be transported at 4 degrees, and travel can take more than 1 day. So the quality at destination depend of the shelf of the cold chain, respect of the cold chain. So Internet of Things consists of putting special sensor that can detect if there is a variation of temperature, recommended temperature, and send instant alert to the transporter, to the farmer, to be aware, but that can be that some problem of temperature can happen. So to make the correction and avoid the loss of quality in the destination.
Thank you. We've got 1 minute left, so Mrs. Labedi, can you just talk about irrigation connected solutions for the last minute?
اوكي ثانك يو. إن اليوم نحب نتحدث مش على الكونكتد سوليوشن فقط، بل كونكتد اند سمارت سوليوشن. irrigation connected and smart. نجموا نلقاو عنا solution يعني متاع irrigation connected مرتبطة عن بعد عبر الواي فاي أو عبر 3-4G، لكن لازم تكون سمارت أنها مرتبطة بالويذر متاع المنطقة. المهمة متاعنا أنه نعطيو لابون كوانتيتي متاع الماء للبلانت في الوقت المعين متاعها، يعني الوقت اللازم متاعها. فالكونكتد أنه تبدأ مربوطة بالويذر متاع المنطقة، في سنسور زي ما قال زميلنا، في سنسور اللي نحطوه بجانب النبتة، فهو يعطينا الهيوميديتي ولا الحرارة في المنطقة، وهو يعدل حسب المعلومات نعدلوا كمية الماء اللازمة اللي لازم نعطيوها للنبتة. يعني نكونوا كونكتد عن بعد، نتحكموا فيها احنا عن بعد، كما تكون الإيريجيشن كونكتد على الويذر الريال يعني في المنطقة، ونعدلوا الكوانتيتي متاع الماء حسب الحرارة ولا الرطوبة أو الريح أو الأمطار، يعني نغيروا حسب المعلومات اللي نحبوا عليها. كل شيء يكون كونكتد عن بعد، يعني نقدروا نبدلوا عن بعد أو هو يغير لوحده من غير ما احنا نعملوا ندخلوا على البرنامج.
Thank you.
Thank you.
We've come to the end of the panel, and I'd like to thank you very much. Please give the panelists a round of applause. And if you could stand over here and have a photo if you could stand underneath your photograph, that would be fantastic. I would like to say thank you very much to all the speakers we've had today, and a particular thanks to all the students that have joined us. I hope you learned something today. We loved having you here with us, and we'd love to see you again tomorrow if you've got the time. We have another full-packed day of information and knowledge for you to take away and use in your projects and your essays and your exams. The more knowledge, the better. And thank you very much for joining us today, and we will see you tomorrow. Thank you.